Unit 8, video number 3, this is page 3 at the top, and we are going to focus on how to balance equations. All balanced equations must follow the law of conservation of mass, which means that matter cannot be created or destroyed. Therefore, mass of reactants equals, all capital letters, the mass of the products. So they are equal before and after. You can never lose mass. If it appears that some mass was lost, it's probably escaped as a gas and went into the atmosphere. So notice here, before the reaction, we have 300.23 grams, and then we cause the reaction to happen, and then afterwards we have new things. However, the mass still remains the same, 300.23 grams. Look at this example reaction. We have a carbon here, I colored it in red for you, and we have one carbon on the right-hand side. We have 4 hydrogens, which are kind of white in color, and then we have 4 hydrogens on the right as well. On the left we have 4 dark gray oxygens, which I colored blue, and then here we have 4 dark gray oxygens, which I colored blue. So notice that before and after this reaction we have 1 carbon, 4 oxygens, and 4 hydrogens, but they're all attached in different ways. So notice that we had our oxygens paired off, but now the oxygens are rebonded to the carbon and to these 2 waters. So we have to have 1 of this methane, 2 of these oxygens, 1 of this carbon dioxide, and 2 of these waters in order to maintain a total of 1 red, 4 blues, 4 whites. If we did not have this, and if we did not have this, then we wouldn't have a balanced equation. Notice you would only have 1 red on each side. You'd only have 2 grays on the left, but you'd have 3 on the right, and then you'd only have 4 whites on the left, but only 2 on the right. So if we don't have 2 of this molecule and 2 of this molecule, then you don't have a balanced equation. Now let's look here. We have hydrogen. So we have a hydrogen molecule, so I'll draw a hydrogen molecule there. We have oxygen, so I'll draw an oxygen molecule here. And then we have a water, and in order to draw the water, we should have 1 oxygen and 2 hydrogens. And I'm not going to color them in, I'm just going to leave it like that. So right now, as it stands, I'll color this one. Right now, as it stands, we have 2 hydrogens on the left, 2 hydrogens on the right. We have 2 oxygens on the left, but only 1 oxygen on the right, because see, H2O, this only has 1 oxygen. So right now, this equation is not balanced. So what could I do to balance the equation? Well, 2 hydrogens, that's fine. But here, 2 oxygens versus 1. I actually need a second water molecule in order for this to be balanced, because that would give me a second oxygen, right? So I'm going to have another water molecule. So that would be a coefficient of 2 that I would place there. And so that's 2 oxygens, and then this 2 multiplies to each of these guys, so it gives me 2 oxygens. 2 oxygens, 2 oxygens. But my problem now is that on the left I have 2 hydrogens, but on the right hand side I have a total of 4. So to fix a balance of hydrogens, I'm going to actually need another hydrogen molecule on the left hand side. So that means I need 2 of this. And now that I have 2 of these, I now have a total of 4 oxygen and 4 hydrogens on both sides. I'm sorry, 2 oxygens on the left, 2 oxygens on the right, 4 hydrogens on the left, 4 hydrogens on the right. So now this is balanced with 2 hydrogens, 1 oxygen molecule, and 2 water molecules. Let's see here, we have an aluminum atom, and we have 3 bromides attached to it. 1, 2, 3. Okay, so these are bonded together, and it's 1 aluminum, 3 bromides. And I'll color in with some stripes my little bromine there. So on the right, I'm sorry, my aluminum. So on the right, we have 1 aluminum And here we have two bromines that are actually hooked to each other, and so I'll draw them attached to each other. So this is AlBr3, this is Al, and this is Br2. Do we have a balance of everything before and after this reaction? Well, we have one aluminum on the left, one on the right, so that's good, but we have 1, 2, 3 bromine on the left and 2 on the right, so that's not balanced. So how can I balance that? Well, 2 times 3 has a lowest common factor of 6, so if I actually had 6 bromines on both sides, then this could work. So in other words, over here, I would need a total of 3 pairs of bromines. That's 2, 4, 6. And over here, I'm going to need a second aluminum bromide in order to have 3 more bromides on this side. So now if I look at my bromines, we have 1, 2, 3, 4, 5, 6, and over here we have 1, 2, 3, 4, 5, 6. So this means I have a coefficient of 3 here and 1, 2, a coefficient of 2 here. But that messes with my aluminums. See, now I have 2 aluminums before, but only 1 after. So to fix it, I can just add another aluminum, so meaning I should have a coefficient of 2 there. So we have 6 bromines on both sides and now 2 aluminums on both sides, and my coefficients are 2, 2, and 3. Now please jump to page 13 and let's look at part 2 of the homework, and we're going to practice how to count the number of atoms in a compound. Subscripts tell you how many of each you have, so this compound has 2 lithiums, it has 1 sulfur, because there's a subscript of 1 understood there, and it has 4 oxygens. So we have 2 lithium, 1 sulfur, 4 oxygen. In number 2, there is 3 magnesiums, because that 3 only goes to magnesium. 3 magnesiums. And then inside of the parentheses, there's a subscript after it, which distributes or multiplies into the parentheses to only everything inside of the parentheses. So here we have 1 phosphorus, but it's 2 times 1 is 2 phosphorus, and this is 2 times 4 is 8 oxygens. So this has 3 magnesium, 2 phosphorus, and 2 times 4 is 8 oxygen. Now here we have a coefficient also, so you're going to have to multiply that to each subscript to take it into account. So for calciums, we have 1 times 3 is 3 calciums. And watch carefully, for my oxygen, it's 2 times 1 is 2, and 2 times 3 is 6 oxygen. Let's watch that again for hydrogen. We have 2 times 1 is 2 hydrogen, and 2 times 3 is 6 hydrogens. So we'll put a 6 there. Okay, let's try number 4. We have this 2 coefficient in front, so take your subscripts and multiply them by that coefficient. 1 sodium times 2 is 2 sodiums. 2 carbons times 2 is 4 carbons. 3 hydrogen times 2 is 6 hydrogens. And 2 oxygen times 2 is 4 oxygens. Let's do number 5. Remember, this subscript multiplies into the parentheses, and your subscripts also multiply to the coefficient. So let's watch carefully. We have 3 times 1 is 3, and 3 times 3 is 9 nitrogen. All right, next, 3 times 4 is 12 hydrogen, and 12 times 3 is 36 total hydrogen. This is 1 times 3 is 3 phosphorus, and this is 4 times 3 is 12 oxygen. Back to page 4, and now we're going to balance the equations on page 4. Skip to this section that says Balancing Equations Practice, and we're going to start with this first one. So to balance an equation, you can only change coefficients to balance an equation. You can never change subscripts. So I can put a big number in front of these because that indicates I have multiple of that molecule, but I cannot change this subscript because then that would actually change what my substance is. For example, O2 is the oxygen that you breathe, but if I change that to O3, it becomes the ozone in the atmosphere, which if you were to breathe that directly, it's poisonous. So we do not change subscripts because then that would change what we have. Okay, so I'm going to deal with these elements one at a time from left to right of my reactants until they are balanced. I need the same number of each on both sides of the equation. So let's just dive right in. I have 4 phosphorus on the left side of my yield sign, and I have only 1 phosphorus on the right side of my yield sign. So if this is 4 and this is only 1, I need to change this one to be 4 also. In order to do that, I'm going to place a 4 in front because 1 times 4 is 4. So now I have 4 phosphorus on the left and I have 4 phosphorus on the right. Phosphorus is good. Now let's look at chlorine. I have 2 chlorine on the left and I have 5 times 4 is 20 chlorine on the right. So I need 2 times whatever that number is to equal 20, so that I have 20 chlorines on both sides. So 2 times 10 would give me 20 chlorines. Let's make sure everything is balanced now. I have 4 phosphorus, 4 times 1 is 4 phosphorus. You can leave it blank or you can put the 1, either way. So 4 times 1 is 4 phosphorus, and over here I have 1 times 4 is 4 phosphorus. So we have 4 of those, we're good. And then here we have 2 times 10 is 20, 5 times 4 is 20. So now I have an equal number of phosphorus and chlorine on both sides of the equation. Let's look at this next one. 2 aluminum, 1 aluminum. So in order to fix that, I'm going to put a 2 here because 1 times 2 equals 2 aluminum. And this 2 times 1 is equal to 2 aluminums. Okay, so we have our coefficients here. Now let's look at oxygen. We have 3 times 1 is 3 oxygen, but over here 2 times 1 is 2 oxygen. So I'm going to need to address this difference, the 2 and the 3. The common factor of 2 and 3 is 6. So I want to make it to where I have 6 oxygens on both sides in order for them to be equal. So 2 times 3 would make this equal 6, and then 3 times, I'm going to change this to a 2 because 3 times 2 would make this a 6. So my oxygens are good, but when I put this 2 here, I modified the aluminum. So let's go back and take care of that. Now I have 2 times 2 is 4 aluminums, and over here I still only have 1 times 2 is 2. So I need this to become a 4 in order to match this one over here. And you can literally just change that 2 to a 4, and now I have 4 aluminums. So it is 4 aluminums, 2 times 3 is 6 oxygen, 3 times 2 is 6 oxygen. So this has a coefficient of 2, 4, and 3. Example, we have 1 iron, 2 irons. So we have 1 versus 2. So to fix it, I want to change that to a 2. So I'm going to put a 2 in front, and now that makes this equal to 2 iron. Okay, now I'm done with iron. Let me scratch that out because I'm done with it. It's even now, 2 and 2. Now let's look at nitrogen. We have 2 versus 3. That's 2 versus 3. So in order to make these equal, I'm going to multiply them to each other and make it equal to 6. So in order to have 6 on both sides, this is going to need a 3 because 2 times 3 is 6. So that's fixed. And then this one over here is going to need a 2 in front, which means 3 times 2 will give me that 6. Now, I have modified my iron, so I need to go back and fix that. So we have 2 irons on the left side, but over here I have 2 times 2 is 4. So I need to address that. Let me get rid of these 6's because we're done with them. So 4 versus 2, I need to change this to a 2 and to a 4 to match. And you can actually just change this to a 4, and now I have 4 irons on both sides. So we can scratch these out because we're done with them, and our final answer is 4, 3, 2. Get into some balancings with polyatomic ions, which are these guys that are circled. So we want to treat them like a bundle. And so if we look in the equation below, the question is, what can I bundle together? And you can bundle this PO4 that you see in parentheses, which is phosphate, and I'm going to circle it on both sides of the equation. And then we're going to just treat those as one unit. So if you look here, that subscript means I have 2 phosphates on the left, and this subscript means I have 4 phosphates on the right. So now let's balance them. We have 1 silicon, 3 silicon, so I'm going to put a 3 here, and now I have 3 silicon, 3 silicon. Let's look at oxygen. 2 times 3 is 6 oxygen, versus only 1 oxygen. I need to make this equal to 6 because 2 times 3 is 6, and now 1 times 6 is also 6. Okay, moving on to magnesium. We have 3 magnesium, but over here we have 6 magnesium. So in order to make this equal, I'm going to put a 2 in front because 2 times 3 will give me 6. Now I can do my phosphates. Notice it's 2 times 2 is 4 phosphates, and over here we have 4 phosphates, and so those are balanced. Let's just recheck everything to make sure. 3 silicon, 3 silicon. 2 times 3 is 6 oxygen, and that's 6 oxygen. 3 times 2 is 6 magnesium, and this is 6 magnesium. And then 2 times 2 is 4 phosphates, and that is 4 phosphates. So we have 3, 2. This one's left blank, so we can put a 1. And so it's 3, 2, 1, and 6 are these coefficients. Now you should be at the top of page 5, and let's start balancing these equations. First, what can I bundle? I can bundle the SO4 over here. Be careful that 2 goes with that hydrogen. And I can bundle the SO4 that is over here. Now notice they're not in parentheses, which means automatically you have 1 of that sulfate and you have 1 of that sulfate. Unless there's parentheses with a subscript after it, you only have 1 of that bundle. Okay, let's balance. 1 barium, 1 barium, that's good. 2 chlorine, 1 chlorine. And so to fix that, I need to put a 2 here because that's going to give me 2 chlorine, but notice it also gives me 2 of that hydrogen as well. All right, so barium, 1, 1, chlorine, 2, 2, hydrogen, 2, 2, that's good. And then the sulfate, 1 and 1, because there's no coefficients in front of these. So I'm going to go ahead and put coefficients of 1, and this is considered now a balanced equation. Example, what can we bundle? We can bundle this OH in parentheses, which is hydroxide, and over here we'll bundle the OH in parentheses. And so notice this has a subscript, so there's 3 of them. This has no subscript, so there's only 1 of it. Okay, so let's balance. 1 iron, check. Notice that when I balance, I'm balancing these one at a time from left to right. I'm going to do iron, followed by chloride, followed by sodium, followed by hydroxide. Okay, so the irons are good. Chloride, 3 versus 1. So to fix that, I'm going to put a 3 here because that's going to give me 3 of this and 3 of this. So chlorides, 3 and 3, good. Next, the sodium, 1, 3. So I need this to also be a 3. So iron, 1 and 1, chloride, 3 and 3, sodium, 3, which is going to give me 3 sodiums and 3 of this, and then this is 3 sodiums. So now I have 1 times 3 is 3 of that hydroxide, and look, we have 3 hydroxides here. So this is finished. We have a coefficient of 1 there and a coefficient of 1 there. All right, what can we bundle here? A few things, actually. We can bundle the hydroxide on the left, and we can bundle the phosphate on the right, the second compound. Over here, here's my phosphate on the right side of the reaction, but where's my hydroxide? I don't see an OH. It's actually hidden in the water. I'm going to change water from H2O to HOH, and there's my hydroxide. So I'm going to use that HOH instead of H2O. And so now I have my bundles. Notice there's 2 of that. Look, no subscript. There's only 1 here. No subscript. We've only got 1 here. That has a subscript, so that means we have 2 of this. Okay, so let's balance. 1 nickel, 3 nickel. So to fix it, I'll put a 3 here. Now I have 3 nickel, and I have 3 nickel. Notice hydroxide. Watch carefully. 2 hydroxides times 3 equals 6 of them right there. So over here I have 1. So to fix it, put a 6. And now I have 1 times 6 is 6 of that hydroxide up there. All right, I'm going to scratch this out because hydroxide is balanced. Nickel is good. Hydroxide, 2 times 3 is 6. That gives me 6 of those and 6 of those. So that's good. Let's move on to hydrogen. 3 versus 6. So to fix it, if I put a 2 there, I have 3 times 2 is 6 hydrogen, and this is 6 hydrogen. So now the hydrogens are good. Finally, I'm going to do the phosphate. This is 1 times 2 is 2 phosphates, and look, 2 phosphates, because there's no coefficient there. So 2 times 1 is 2. So I have 2 phosphates on both sides. They are good as well. That's going to have a coefficient of 1, and we're finished. This is the last example we'll do from the note pack. So I can bundle this SO4 and this SO4. So now when I balance, I have 1 aluminum, 2 aluminum. That's going to put a 2 here. Now, let's balance bromine. 3 times 2 is 6 bromine, but over here I only have 1, so I'll put a 6 there to fix it. So that's going to give me 6 hydrogens and 6 bromines. Okay, so aluminum, check. Bromine, check. Hydrogen, I've got 2 on the left, 6 on the right. So if I put a 3 here, that'll be 3 times 2 is 6, and notice that now gives me 3 of that sulfate bundle. But focusing on hydrogen, 3 times 2 is 6 versus 6, that's good. Finally, the sulfate, we have 1 times 3 is 3 sulfates, and look, 3 sulfates. So we're all done. This is going to get a 1, and you're done balancing it. This problem should be omitted because it doesn't have anything different before and after, and we'll do the last problem really quickly. Can you bundle here? Nothing. Don't bundle. Don't change the water. There's no hydroxide over here, so we're just going to balance it as it stands. 2 iron, 1 iron. Fix it with a 2. 3 oxygen, 1 oxygen. Fix it by putting a 3 here. So iron is good. Oxygen is good. Notice that goes to both of them. Now hydrogen, 2 on the left. 3 times 2 is 6 on the right. So look, I'll just put a 3 here, and now I have 3 times 2 is 6, 3 times 2 is 6. 2 irons, 3 oxygen, 3 oxygen, 3 times 2 is 6 hydrogen, 3 times 2 is 6 hydrogen, and now this equation is also balanced. I'll be able to turn to pages 13, 14, and 15 and complete parts 3 and 4, which are all balancing equations to follow the law of conservation of mass.